Okay, today we're going to talk about solving a system of equations using substitution. A system of equations is two equations, so I do have the two equations here, and they have to have the same variable, so you'll notice they both have x and y. So we're going to be solving this by using substitution, and the goal is to get an equation with only one variable in it so that we can solve it, because we can't solve with the two. So in this case, you'll notice they both have two variables, and so we're going to substitute. And if you notice, we know what x equals. X equals 3y, okay? So I'm going to substitute that for the x here. So I'm going to rewrite it, and instead of writing plus x, I'm going to write plus 3y. And you notice what I've done is eliminate the x in there, and all I have is the y. And then I'm just going to solve this using my equation solving principles. So 2y plus 3y is 5y. So it looks like this, 5y equals negative 15. And then I'm going to divide both sides by 5, and we get y equals negative 3. All right, so I know that when I'm finding a solution to a system, I need an x and a y. I'm making a coordinate pair. In this case, the y of the coordinate pair is negative 3. So I'm going to plug that in. Now that I know that y equals negative 3, I can plug that into either the top equation or the bottom equation, whichever one's going to be easier. I'd get the same answer no matter which one I do. But the bottom one to me is much easier because all I have to do to find x is multiply 3 times whatever I found y to be, which in this case was negative 3. So 3 times negative 3 is negative 9. And now that is my x coordinate that goes in here. So if I were to graph these lines, they would intersect at negative 9, negative 3. And that's how I would do that problem. Now I'm going to show you a few different kinds of problems. So let's get rid of this one. And we're going to do another one where we have y's by themselves. So we have y equals x plus 1. And I have y equals 2x minus 4. Let me make that neater. I don't like that. Okay. So again, we have a system of equations. We have two equations. They have the same variables. They both have x and y. So I want to find their solution, which means where they intersect if I were to graph them. So what I do know, I know y equals x plus 1. And since I know that y equals x plus 1, I can substitute that in for that y. All right, so I'm going to substitute this x plus 1 in for the y in the other equation. And I'm going to rewrite it. So instead of writing y, I'm going to put x plus 1. And this side doesn't change at all, and it looks like that. Now I'm just going to solve using my equation solving principle. So I'm going to move the variable to one side. So to get rid of this x on this side, I'm going to subtract it. Remember that when we move variables from side to side, we use addition or subtraction. So x minus x is 0. I'm left with 1. I have 2x minus 1x. It's going to leave me with 1x that I'm just going to write as x. And now I have to get rid of the number, the minus 4, so that the x can be alone. So to get rid of a subtracting 4, I'm going to add 4. I'm going to add 4 to both sides. When I do that, I get x equals 5. So in my coordinate pair, I know that I have x equals 5, so I'm going to put it there. Remember that it's very important to put the x as the first one and the y value as the second one, because that's how a coordinate pair works. Otherwise, you'll be saying that it intersects at the wrong intersection point. Okay, now that I know that x equals 5, I'm going to plot, I can put that back in the top equation or the second equation. I'm going to plug it in for x. Okay, so I'm going to take this 5. I like the top equation, and I'm going to plug it in right there for that x. So instead of writing that x, I'm going to write 5, and it's just 5 plus 1. And so the y equals 6. That's my y value. So my solution to my system is positive 5, positive 6. If I were to graph those lines, that's where they would intersect. All right, now we're going to do one that's a little bit more difficult, but this is the hardest you'll have for a substitution problem. And it looks like this. We have 5x equals 15 plus 10y And then we have 3x plus 5y equals 31. Okay, you'll notice that none of the x's or y's are by themselves. They all have numbers next to them. And so we have to do a little work before we can do any substituting, because in order to substitute, I need the x or the y by itself. To me, the easiest one to get by itself is going to be this one right here, because it's being multiplied by 5, and all I have to do is divide by 5. So I'm going to do that. I'm going to do it over here. So we have 5x equals 15 plus 10y. And in order to get this x alone, I have to divide by 5. I'm going to divide each item by 5. When I do that, I get x equals 3 plus 2y. Now I know what x equals. X equals 3 plus 2y. So I'm going to plug this 3 plus 2y in for that x. Okay, so I'm going to do 3. And the 3 is multiplying by the x. So I'm going to multiply it times the 3 plus 2y, aka the x, right? And then we're going to just keep writing the 5y equals 31. And now I'm going to do distributive property. So now I'm just solving. So I have 9 plus 6y equals 5y. No, I'm sorry, not equals, plus 5y. Plus 5y equals 31. Now I can combine like terms. I get 11y. So I have 9 plus 11y equals 31. From there, I'm going to erase over here just so I can use the board more efficiently. So I have 9 plus 11y equals 31. From there, I'm going to subtract 9 on both sides, and I get 11y equals 22. And then we can solve by dividing both sides by 11, and we get y equals 2. So in my coordinate pair, I know the y equals 2. Now I have to figure out the x. Since I know y equals 2, I can plug it in here, or I can plug it in here to figure out what the x value would be. So again, I'm going to do a little erasing just because I need a little room here. So I want to plug the 2 in. Let's plug it into this one up here. Okay, so I have 5x equals 15 plus 10, and then I know that y equals 2. So 10 is being multiplied by the y, so I'm going to multiply it by the 2. And then I'm going to just continue my math. So I have 5x equals 15 plus 20. So 10 times 2 is 20. And I have 35 equals 5x. Divide both sides by 5. And I get my x value to equal 7. And that is the solution to that system. And that's as hard as it gets, really, as far as solving system of equations through substitution.